بسم الله الرحمن الرحيم.
Assalamu alaikum students. We are doing chapter number 10. We were doing chapter number 10. Today we are moving on with the topic anomalous expansion of water. Last time we did a derivation which was between two coordinates, two constant which were alpha and beta, and they were basically coefficient of linear thermal expansion and coefficient of volumetric thermal expansion. Getting class? So today's topic is anomalous expansion of water. So before starting the topic, I am telling you effect of heat, the normal effect of heat on anything. As we discussed before, basically as we rise the temperature, what will happen? That material, whether it is solid, liquid or gas, it will start expanding. Okay, this is a normal effect. When we increase the temperature, whether it is solid, liquid or gas, it start expanding. Okay, but if and what will happen if we do the opposite thing, which means we decrease the temperature, it will automatically start contracting. Mean as expanding, its density is, what is happening with the density? Density is decreasing. As but in the form contract, what is happening? Density is increasing. Okay class, so this is a normal effect. When the temperature of anything will rise, it will automatically expand that thing, whether it is solid, liquid or gas. But there is a difference. Expansion in gases are more than the liquid, and expansion is in liquid are more than the solid when we apply heat to that. But what happened, how water behave differently with them, and we have a range which is 0 to 4 degrees Celsius. Okay, so what if we talk about the heating process, it means we have water at 0 degree centigrade and we are heating it to 4 degree centigrade. Getting class? So what will happen? What if we are heating? So the normal behavior is to expand, but water shows a different behavior, and that behavior is contract. Mean when we are heating from 0 degree to 4 degree centigrade, what is happening? That water is contracting. Contracting mean what is happening with the density? Density is increasing. Getting class? And we can say at 4 degrees Celsius water is heaviest. It's mean at 4 degrees Celsius water is heaviest. If we have a bottle, I will show you this with, I will show you what I want to say you about the heavy water with this experiment. But before that, just clear a concept that when we are heating from 0 degree Celsius to 4 degree, what is happening? Water is contracting. Okay, now moving to the expansion. Opposite to this, when we are cooling the water from 4 degrees centigrade to 0 degree centigrade, what is happening? The normal behavior, if we talk about any gas, if we cool down that gas to 4 degrees Celsius to 0 degree Celsius, the normal behavior is it will contract, mean its density will become high. But in the case of water, when we cool down the water from 4 degree centigrade to 0 degree centigrade, what will happen? It will start expanding. Okay, this behavior can be shown by this experiment. This experiment is known as Hooke's experiment. Now look at the apparatus of the experiment. What they are doing actually, this is a container, this is a cylinder. This cylinder, main cylinder is filled with water. Getting class? And there is a trough, and this trough is filled with ice and salt, a freezing material. Ice and salt. Ice means the minimum temperature of this area will be 0 degree Celsius. Getting class? 0 degree centigrade. So this is a trough. Trough is filled with ice and salt. Okay, and this is a cylinder, and this cylinder is filled with the water. We have inserted two thermometers at the bottom, at the top. Okay, and they basically show you the difference between the temperature at the bottom and the top. At thermometer at the bottom is the B1 that is inserted at this cylinder at B point, and temperature thermometer number A, or the thermometer which is inserted upper side of the cylinder is at point A. Getting class? So B and A. So these are the 2 points. A in the top, at the top of the cylinder, B at the bottom of the cylinder. Now what will happen? This is the water, okay, and there is basically freezing material which is ice and salt, okay. So just suppose the normal temperature, we have a graph, and that graph is also showing you the temperature. So the normal temperature, the room temperature, or the temperature of the water is 12 degree centigrade. What will happen? First of all, from this part where ice is present, this water will remove its heat to this ice and start cooling, okay. It will reach to a temperature of 4 degree centigrade. It will reach to a temperature at this area, water will reach the temperature of 4 degree celsius centigrade. So okay, so what will happen? It will become heavy and it will settle down. As I told you there, at 4 degrees Celsius, water is heaviest. It's mean at 4 degrees Celsius, water has a highest density, getting, and it has a it will automatically settle down. Getting class? So what will happen? This portion of water will shift downward and it will automatically settle down. Now what will happen? This area will show you a temperature of 4 degree centigrade automatically. If we take out the reading, mean reading at T2, mean thermometer, this thermometer at point B, from point B, what we are getting, which reading we are getting? 4 degree centigrade, okay. It is because this ice is cooling this portion of water. Water will become 4 degrees Celsius, and as it reach 4, it can go further, but as it reach 4 degrees Celsius, it start settling down because of the heaviness, okay. Because when water comes to 4 degrees Celsius centigrade, it will become heavy, so it will settle down. Getting class? So what will happen? It will settle down, and now this portion is going loses heat to this ice and decrease the temperature of the water, this portion, okay. So what will happen? As this portion will become 0 degree centigrade. Why? Because already we have water with the heaviest, with the 4 degree centigrade, okay. It is already settled down. Now all the temperature which of the water will become 0 degree centigrade, basically at the top surface. Getting class? So top surface, the temperature of the water will be 0 degree centigrade. Now if we draw a graph according to these readings, so look at the graph. At point A, I wrongly mentioned that at point B, we can say at point A. Now look, basically temperature 4 degree centigrade, 0 degree centigrade, and this is the time, okay. So look the graph, temperature is falling, mean decreasing from 12 degree centigrade. As I told you before, that the initial temperature of this water is 12 degree centigrade, so temperature is falling. But at point B, look at the temperature. Temperature will fall to 4 degrees centigrade, and it will stop at that point, 4 degrees centigrade. It will not fall more. Okay, but look at the point A, mean this portion, because it is continuously losing its heat to this ice, so decreasing its temperature. Okay, temperature are always mean heat basically it is transferring the heat, that's why it is losing its temperature. Getting class? And heat always transfer from hot body toward the cold body. We have cold body over there, and this is the hot body. It will lose its heat until they both will be in equilibrium. Getting class? So as this portion will lose heat to this ice and salt freezing substance, so it will come to 4 degrees Celsius and further fall and come to 0 degree centigrade. Getting class? So this was the experiment by which we can find out the anomalous expansion of water. We can find out about this thing that water, when we heat the water from 0 degree centigrade to 4 degree centigrade, what will happen? It will contract. Okay, when we fall the temperature of water from 4 degrees centigrade to 0 degree centigrade, it will expand. What is the normal behavior? Normal behavior is that when the temperature increase, it will automatically expand the thing, as we did in the linear thermal expansion. Okay, there was a rod and we were providing heat to that rod. So what was happening with that rod? That rod was expanding because it was extending its size, getting class on heating. So that was expansion. This is the normal behavior. If we talk about the gas, if we apply heat to a gas, if we raise the temperature of a gas, it will also expand. Expand mean decreasing the density, getting. But in the water, what is happening? 0 degree Celsius, if we are providing heat, what if I am raising temperature from 0 degree centigrade? If we are increasing, basically what we are doing, we are increasing the temperature 0 degree centigrade to 4 degree centigrade. So actually we are providing the heat to it, getting. So when we are providing heat, so what will happen? It will contract, water will contract. And when we are, what we are doing when we are freezing this water, so what will happen? It will automatically expand. But the normal behavior is, what is the normal behavior? When we freeze anything, it will contract, getting. Contract mean the density is increasing, getting class. So this was the experiment. Again repeating you, this is cylinder with the water, this is stuffed with the cooling material or ice, we can say. Two thermometers, the first one at point A, top of the cylinder, the second one at point B, at the bottom of the cylinder. Okay, so we got the reading. At the bottom was 4 degree centigrade and at the top was 0 degree centigrade. These were the two readings which we were getting. Okay, now another thing, when the temperature, first of all, temperature start falling at this portion because this is nearest to the cooling material. Okay, so temperature will fall down and become, it will fall down to 4 degrees Celsius. It can fall further, but before falling further, it will settle down. Basically this is the main point, settling down. This settling down is showing us the water is contract at 4 degrees Celsius, 4 degree centigrade. Water contract at 4 degree centigrade and it contract and it will become heaviest at 4 degrees Celsius, that centigrade. That's why it is falling, settling down at the bottom, getting. So it will automatically settle down and the mass of the water will move over there. The previous mass of the water will move at this portion. Now we have 4 degree centigrade water over there because it is heaviest water. Now all of the water at this portion will further fall, the temperature of that water will further fall to 0 degree centigrade as shown by this graph. And at point B, mean this, the temperature will 4 degree centigrade, but at this point temperature will 0 degree centigrade, getting class. So this was the Hope's experiment by which we were getting anomalous expansion of water, behavior of water, how is expanding by increasing the temperature. Okay, but only this range, between this range 0 degree centigrade to 4 degree centigrade. Okay class, so we have some practical example for this. The first one is the marine water life. In the area where where temperature is below 0 degree centigrade, say much more below than 0 degree centigrade, we know water start freezing at 0 degree centigrade. Okay class, so as temperature fall down below the 0 degree centigrade, so what will happen? If we talk about the sea water, it will freeze. But because of the anomalous expansion of water, what will happen? Only the surface will freeze. The blue water, like this experiment, what was happening? The blue water has a temperature of 4 degree centigrade. This was happened in the this is the thing which happened in the ocean, in the northern or the area where the temperature will was or temperature fall below the range of 0 degree centigrade, getting class. So the surface will freeze, सही है, surface will freeze, but the area below the surface of the ocean keep on 4 degree centigrade. Same as the experiment. Okay, this is a practical example, and it will automatically have marine life, because fishes and other things live in that part as well. Okay, some more example is that some of the pipes in, not in our climatic region but in the northern areas, we can see this, the pipe, water pipe, which is basically exposed to atmosphere, or the which is under the surroundings, where the temperature of the surround is acting. So if the temperature is below 0 degree Celsius, not below degree, if the temperature is below 4 degree centigrade or 4 degree centigrade, it will burst. Okay, and that burst is because of the expansion. Getting class? As the water fall its temperature from 4 degrees centigrade to 0 degree centigrade, okay, what will happen? It will expand, and expansion will increase the volume. Okay, and that volume will automatically burst that pipe. Getting? This is also a practical example of anomalous expansion of water. Getting class? Now we have two more topics which are related to the laws of gas. This was related to the water only. Okay, now we are moving to another topic which is related to gas. Okay, expansion in gases. It is like normal. Okay, we know when we provide heat to any gas, it will expand. Okay, but the expansion in gases is more than the expansion in liquid or the expansion in solid. Mean gases expand most. Okay, class. So if first of all I am talking about these are the basically these two both are the laws of gas. Okay, first I am talking about the Boyle's law. You have to remember, in Boyle's law we have to provide constant temperature. It's mean temperature kept constant, then we are talking about the Boyle's law. So, and we are talking about the gas. Okay, these laws are for gases basically. So when we temperature, just suppose we are doing relation between two, because of the expansion it's mean we are talking about the volume. In the both cases we are talking about the volume. Now what Boyle's law is saying, the volume of a gas is directly proportional to the, not directly, volume of a gas is inversely proportional to the pressure applied to a gas when temperature kept constant. Getting class? It's mean we have to keep the temperature constant, then pressure will automatically decrease the volume. If we increase the pressure, it will automatically decrease the volume. Getting? So volume is inversely proportional to the pressure. This is Boyle's law. Getting class? Boyle's law, when temperature kept constant, volume of a gas is inversely proportional to the pressure. It's mean inversely, what is mean by inversely proportional? If we increase one of the factor between them, the other one will automatically decrease. Getting? It's mean if I increase the pressure, automatically the volume for gas will decrease. This is the inverse relation. Okay, so from there we know that if we want to replace this sign, what we have to put? We have to put a constant. Okay, so I am putting a constant, and this is 1 upon P. Okay, we have constant over there which is k, simply k, and that constant is basically this, that constant is because of the mass. That constant may vary as the mass of that gas may vary. So if you find out the value of that constant, p is dividing over there, it will shift it to this side and it will become pv, mean constant k, p is dividing, I will shift it to that side and it will become multiply with v, getting? So k constant is equal v and p this one. So this will be the formula of constant of Boyle's law. Okay, so if we want to find out a situation where we can find the initial between the relation between initial and final pressure, so we know that constant remains same. Okay, constant remains same, it's mean we can write like this. Okay, if you are talking about the same gas at the initial temperature, at the initial pressure and the final pressure, constant remains same. Your constant depend on the mass. If mass will vary, then the constant will vary. Getting class? So if I am talking about the initial one, so it will be like this: P1 V1 mean initial pressure, initial volume. Okay, if I am talking about this final, so I am like writing it like this: mean final pressure and final volume. So this is the Boyle's law, and this is when the temperature is constant. Mean Boyle's law is the relation between volume and pressure when temperature remain constant. Getting class? Now moving to the Charles law. Okay, so what is Charles law? Here we were keeping the temperature constant, now we are keeping the pressure constant. Okay, now here we have three things: volume, pressure and temperature, in which we are finding the link, so relation. Okay, so volume, pressure and temperature, here we are keeping the constant, here we are keeping pressure constant, it's mean the relation between volume and temperature. Okay, and what is the relation between volume and temperature? Volume is directly proportional to the temperature. Getting? Volume is directly proportional to the temperature. And what is mean by volume? What is mean by the directly proportional? It's mean if we increase the volume, temperature will automatically increase. If I increase the temperature, volume automatically increase. Getting? So here pressure was in inverse relation with the volume. If I increase the pressure, volume will automatically decrease. Okay, and here what is the relation between them? If I increase the volume, temperature will automatically increase. So in other word I can say, if I increase the temperature, volume will automatically increase. Getting class? So again constant is k and this will become t, temperature. So if I want to find the value of k, it will be like v upon t. Getting class? So again if I want to find this form like this, so I am putting two constant, these constants are is equal because we are talking about the same gas, we are talking about the initial and the final situation. Okay, so the constant for the gas will remain same because we are not changing the gas. So initial v upon t, the value of k and the value of k for the both k, in the Boyle's law value of k will be, mean constant will be v upon t, but for this case is the initial and it is the final. So I am putting 1 with the initial volume and the initial temperature. Okay, so v1 upon t1 and v2 upon t2, it's mean initial volume, initial temperature, final volume, final temperature. Okay, so these are the two laws. These two laws are giving us the concepts of expansion and gases. Okay, over there we discuss anomalous expansion of water. And what was anomalous expansion of water? It is between the range of 0 degrees centigrade to 4 degrees centigrade, when we are heating the water from 0 degrees centigrade to 4 degrees centigrade. So normally if we heat anything, so what will happen? That thing will expand. Okay, like this relation is also showing us that expansion. We are increasing the temperature, volume will automatically increase. This is for gas only. Okay, so this is normal temperature. We increase the temperature, volume will increase. But over there, anomalous behavior of water, what was that expansion? What was that expansion? That expansion was when we were applying, when we were rising the temperature of that water from 0 to 4 degrees centigrade. The normal thing is to expand. That water must have to expand, but that water was doing something different. That water was contracting. Getting? Mean, if we were providing a higher temperature to that water, if we were providing heat to that water, so that water was contracting, and it will contract the most at 4 degrees centigrade. Getting? 4 degrees centigrade, water has the highest density at 4 degrees centigrade, and it has a heaviest mass as well. Okay, so at 4 degrees centigrade, water has highest density and it is heaviest. So that was the anomalous expansion of water between the range of 0 degrees centigrade to 4 degrees centigrade. Okay, and here we are talking about the expansion in gases. And expansion is gases basically is when we increase the temperature, it gases start to expand. This law is showing us same. First I am repeating this law, Boyle's law, and what that law is saying, what is the statement of this law? Volume of a gas is inversely proportional to the pressure of applying to that gas if temperature kept constant. It means we are keeping the temperature constant, and if we are providing pressure to a gas, its volume will automatically decrease. Okay. Now Charles law. What Charles law was saying, when we kept the pressure constant, okay, then volume is directly proportional to the temperature of the gas. Temperature which temperature we were providing to the gas, that if we rise the temperature, volume will automatically increase. Getting? So temperature increase mean volume increase, mean expansion. So we can further solve this law, mean we can further find a relation between these terms. We know that volume is directly proportional to the pressure, not directly, this is inversely. Volume is inversely proportional to the pressure. Okay, so we will replace this sign by is equal and constant. We will find out the value of constant, and it will become like pressure is dividing here. I will shift it to that side, and it will become multiply with V. Okay, so we are taking two constant is because if we are talking about the same gas, why I am finding this situation? Because if I want to find the initial link and the final link between pressure and the volume, okay, what is the effect when the initial pressure was, just suppose 70 torr, okay, and the volume was at 3 liter. Okay, so this was the initial, and now what I am saying, I am increasing the temperature to 100 torr. Now what will be the volume? Okay, so this relation is showing us the relation between initial and final stage. Getting? So if we are given with the any three values, we can find the fourth one easily by this relation. For the same gas, this relation is for the same gas but different condition, initial and the final stage. Okay, in the same way like I did here, I am doing here V. Now this sign will replace by is equal and the constant, and this T will remain same. Okay class, so if I find out the value of K, so it will be like V upon T. Now we know that constant remains same for the same gas, so K is equal to K. Now at one place I am putting this value, and for this K I am putting this value. So V2 T2, oh okay, V upon T. I am putting 1 for the initial one and putting 2 for the final one. Getting? So this is the relation, and like that it is same. If we have any three values from them, we can find the fourth one easily. Okay class, so if we draw a graph for these two laws, I am increasing the pressure, okay, and mean this is the pressure in this direction and this is the volume. We have to find out the link between volume and pressure. So this line is showing volume, mean if I increase this line in this direction, mean I am increasing the volume. If I will increase this line in this direction, it means I am increasing the pressure. So the curve will be like this, okay, and this curve is basically what this curve is showing as pressure, because we are moving in this direction from here to here, mean in this area, so we are increasing the pressure. So as the pressure is increasing, automatically volume is decreasing, because look at the line on the vertical axis, it is coming down. Volume was this, but as we increase the pressure, volume become this, it's mean volume decrease. So pressure was this, but as I increase the pressure to this, getting, so I am increasing the pressure, volume is automatically decreasing. So I can show you like this as well. Getting students, so this will be the graph of Boyle's law. Now if we talk about the graph of the Charles law, the graph will be like this, because the volume, they both have the same effect. If I increase the temperature, volume will automatically increase with the temperature. Okay, from here, if this, it will end at 0 degree centigrade. If I extend this line to a value, just suppose this is a chart where we have the value of volume. Okay, now what we were doing, I am taking this as volume, okay, and this is temperature. So volume is decreasing, okay, and this is the temperature. So as I am moving there, it's mean I am decreasing the temperature. So what, look, volume is automatically decreasing. Directly proportional also mean this class, okay, as we decrease it, the same effect with this, mean if I decrease the temperature, volume will automatically decrease. It also means this, if I increase the volume, if I decrease the pressure, volume will automatically increase. Mean inverse, mean if I am doing anything with the one thing, one property, reverse is happening, opposite is happening with the other one, but in the direct, same will happening with the other one. Okay, so this will be the graph. So at a point, that point is 2 minus 273 degree centigrade. At this point, if I increase this gradient, so what will happen, at this point the volume of a gas become 0, volume of a gas will become 0 liter, okay, or so 0 liter, or we can say other thing, it will become 0. So this is untangible reading, okay, it is not acceptable, because 0 volume mean nothing. But we know, and this temperature is also known as, we discussed about Kelvin scale, this temperature is also known as 0 Kelvin, okay, and we were saying it absolute 0. When, why we were saying it absolute 0, because this is the temperature where, first of all, this is the lowest temperature we can ever get, okay, and the second thing is 0 Kelvin mean absolute 0. This is because at this point, movement of the molecule inside the matter will stop. It's mean, if I have a metal rod and I put that metal rod, or if I have a gas, if I make the temperature of the gas fall to minus 270 degrees centigrade or to 0 Kelvin, the molecule, movement of the molecule of a gas will automatically uh, become stationary. They will become stationary, they will stop moving. Okay, same with all of the metals, solid, liquid or gas. If I can fall the temperature of that matter to minus 273 degrees centigrade, we know the kinetic molecular theory of a matter, and that is molecules are continuously moving. In the solid state they are vibrating, in the liquid and gas they are moving, so that movement become 0. That's why we are saying it to 0 Kelvin. But here we are getting another wrong concept, which is 0 liter. So this is because this law is only applicable for gases. But as we decrease the temperature of any gas, it will automatically liquefied. if if I decrease the temperature of a gas, just suppose if I am decreasing a temperature of a gas from 0 to 40 minus 40, so what will happen? It will automatically liquefied at minus 40. Now Charles law will not applicable for that gas because it become liquid. So that's why according to this graph we are getting at a minus 273 degrees centigrade or 0 Kelvin, volume become 0. But this is only showing us about the gas, but at that temperature it will not be the gas, it will become liquid or something else. Getting? Okay, so these three are the topics, are today's topic. Now I am moving to the homework, and your homework is to practice the derivation which we did last time, mean derivation of thermal expansion. Getting class? Linear thermal expansion, volumetric thermal expansion, and the relation between coefficient of both linear and volumetric. Allah Hafiz.